Please begin this segment by working on the prerequisite skills without using your calculator, and you don't have to reduce this fraction. Change these decimals to fractions, multiply here, divide here. All right, so pause the video and try this. So from basic skills, you would remember that to change decimals into fractions, you just read the decimal. All right, so that would be 42 10,000ths. All right, this would be 817 thousandths, and that would be 53 hundredths. Then when we go to multiply by powers of 10, all you have to do is count up the zeros. So there's a total of 3 zeros here, 4 zeros here. So I need a 1 with 7 zeros. So that should be 10 million. All right, so for multiplying powers of 10, we count up the zeros. All right, for dividing by powers of 10, what we do is we take our decimal point and we move it to the left as many places as there are zeros. So the decimal point on 25 is here. We move it 4 places to the left and fill in with the appropriate amount of zeros. So this would be 2 zeros and then a 2, 5. Right? And then here I would count 3 places to the left. So that would add 1 0 and I'd get here. Okay, so these are skills we're going to need to verify our why we do what we do thing to multiply decimals. And I know that you do this so briefly in school and then you switch over to a calculator that I feel like virtually no one anymore nowadays has mastery of this. All right, back in the 80s, I spent hours and hours multiplying and dividing decimals out by hand. All right, that just doesn't happen anymore. Okay, but you should still know how to do this. So to multiply decimals, what we do, so we're going to make my favorite, the what why chart. Okay, so the what we do and the what we do and the why we do it. So I know some of you are still even a little bit shaky on the what side. Okay, but what we teach kids about to multiply decimals. All right, so let's start off with a really easy problem like 0.2 times 0.3. Right, and some of you are going to say, oh, that's so easy, 0.6. Right, the way that we show this is not 0.6 is if I changed these both into fractions. Right, what I actually have is 2/10 times 3/10. Okay, so not only do the 2 and the 3 have to get multiplied, but the 10th and the 10th have to get multiplied as well, right? Which shows me that this is 6 hundredths. Okay, so what we teach kids to do is we tell them to take the two numbers and multiply as if they're whole numbers. Okay, so that's step 1 that we give them. Okay, then we say, count the places to the right of the decimal point. How was I supposed to know that I had to move 2 places over? All right, it looks like I would bring the decimal point straight down. Okay, so we teach kids count the places to the right of the decimal point. So there were 2 places to the right of the decimal point. All right, so we multiply them like they're whole numbers. We get 6. Then we know there's 2 places to the right of the decimal point. So then we would tell kids, okay, after you multiply these and get 6, so let's pretend we don't know the answer. After you multiply these and get 6, what you do is you take the number you counted up here, the 2 places, and then you move the decimal 2 places from the end. All right, and so that's the procedure that we give kids. Okay, so step 3 here under the what. Move decimal point in the answer left as many places as counted in step 2. Okay, so now we have to go over to the Y section. So let's take a look at another problem that's a little bit more difficult than this one. So let's look at the problem, say, let me get a nice clean piece of paper too. Let's look at 0.318 times 4.2. Okay, so we would tell the kids, ignore the decimals and just multiply that. Okay, so that would be 628, and that would be 272. Okay, so we get here. Okay, but let's look at what this would be if I changed it to a fraction. That would be 318 thousandths. Multiply that by 4 2/10. So let's see, 4 2/10. I am going to change that. Let me write this over here. 4 2/10. I'm going to change that into an improper fraction. 42 tenths. Okay. So when I tell you, or when I tell my students to just multiply them like they're whole numbers, when I go to multiply these fractions, numerator times numerator, they are whole numbers, right? If I multiplied this out, I would get this. So if I'm multiplying them in fraction form, I get this over, well, how many zeros do I have in my denominator? I have to count up how many zeros I have. Well, let's see, I have 3 zeros here. I have 3 places to the right of the decimal point, right? I have 1 0 here. I had 1 place to the right of the decimal point. All right, so notice when I count up the zeros to go and multiply my denominators, there's 1 0 per every place to the right of the decimal point. All right, so when I'm counting up places to the right of the decimal point, I'm really counting up how many zeros I have in my denominators. All right, then I tell the kid, move to the left as many places as you have zeros. Well, that's how I divide by a decimal. Or I'm sorry, not divide by a decimal, divide by a power of 10. Right? I divide by a power of 10 by counting up the zeros and moving my decimal point 1 place to the left for every zero. Okay, so if I want to put that into the Y chart, over here under the Y side, let me make a step 0 though. Okay, so this starts before I multiply them. So on the Y side, write as fractions. I'm going to do that before I even start the problem. Then step 1, well, when I do numerator times numerator, right, they are whole numbers. So I tell kids multiply them as if they're whole numbers. Well, they are if I change them to fractions. Numerator times numerator, they are whole numbers. Okay. Then for step 2, count the places to the right of the decimal point. What I'm really doing is I'm counting zeros in order to multiply denominator times denominator. Right, so that's how I multiply powers of 10. Say that. Counting zeros is how I multiply powers of 10. Okay. Then for step 3, move the decimal point as many places to the left as counted in step 2. to divide a whole number by a power of 10, I move decimal point one place left for every 0. Okay, and so here's the what I do, here's the why I do it. All right, so pause your video, copy this down, then we'll move on to division. Okay, when we go to divide decimals, if I were to think about the partitive concept, and how would I partition into, say, 7/10 of a cup? What would that look like? All right, and I can't partition into 7/10 of a cup, but I could partition into 7 cups. Right? I could lay out 7 cups. So I want my divisor to be a whole number. All right, so that's always the goal, is we always teach kids, move the decimal in the divisor so that the divisor is a whole number. Okay, so that's what we teach kids to do. Now, second thing we tell them is however many places you moved, when you moved the decimal here, you move the same number of, so this is your divisor, right? Your answer is your quotient. The part underneath is called the dividend. So however many places you move the decimal in the divisor, you move also in the dividend. All right, let's look at why that is true. All right, if I wrote 42 over 0.7, if I wrote all my division problems like this that I've shown on this paper, right? So this one is 35 over 0.05. What I'm really doing is you could call this making use of equal quotients, or remember, making use of equal quotients is just dividing by 1. Okay, because again, another way I could write this is I could write it like this. Right, so this division problem can be either written with this box, it could be written as a fraction, it could be written out like this. So my rule of equal quotients tells me if I want to move the decimal 1 place, that is really just multiplying this by 10. Right, so here's my law of equal quotients. Well, my law of equal quotients always just boiled down to multiplying this, multiplying by 1. There's one of my legal moves, that I can take my fraction, I multiply it by 1, and I don't change the value. I change the appearance, not the value. So then I get to here, right? You add your decimal point here if you need it. I don't even need it in this case, but you add it here, you bring it straight up, and then you just do regular old division. So that would be 6 or 6.0. Okay, so the reason we move the same number of places in divisor and dividend is because of the law of equal quotients. Now, one of the mistakes that students often will make is they'll say, oh, I moved the decimal 2 places, so then do I have to move it back at the end? Usually when students get this wrong, they think they have to move the decimal back at the end. All right, I don't do that because I have created an equivalent problem. Right, this changes the appearance and not the value, because when I multiply by 100 over 100, right, this new division problem, I just changed the problem to 5 goes into 3,500. This has the same result as it did before I moved the decimal. All right, because all I did is multiplied by 1, or I could think of that as applying the law of equal quotients. So, just thinking if I want to say anything else before I stop the video. Let's see. Let's just do a real quick Y chart. And then the very last thing you do is on the last page of this handout. So this is for dividing. The last page of this handout, I just want you to, for classwork, find which of these has this same quotient. Okay, so anything is equal if I've applied the law of equal quotients to it, right? Or if I've moved the decimal the same number of places in divisor and dividend, all right? So you're going to submit this for classwork. Okay, so let me just rattle off a quick what Y chart for dividing by decimals, and then we're done with the course. Okay, so we move decimal in divisor to make divisor a whole number. Okay, so that's step one. Move decimal the same number of places in dividend and then we just bring decimal point up, right, straight up, and then we just do regular old division. Okay, so over on the Y side, why do we do that? Because we're using the partitive concept. Right? I can't have 0.7 groups. Right? I can have 7 groups, but I can't have 0.7 groups. That wouldn't make any sense. All right? Why do I move the decimal the same number of places in divisor as dividend? That's my rule of equal quotients. Bring the decimal point straight up. Right? I do that to maintain place value, and then I do regular old division. So congratulations, you finished the course.